Okay, we're starting chapter 9 today, and this is going to build on chapter 8. So we've studied chemical equations. Let's review briefly. A balanced chemical equation gives us relative numbers of reactant and product molecules. So, one of this and two of that. And if it gives us relative numbers, then it also would give us relative moles, because a mole is just a counting unit like a dozen. So it gives us relative moles of molecules of reactants and products. The coefficients are what give us the relative numbers of molecules or moles of molecules. Oh, I forgot to get rid of the animations on this guy. Hang on a minute. So we can think of a chemical equation as being a lot like a recipe. Cooking is actually a lot like doing chemistry, and it does involve some chemistry. You have some instructions, you mix this and this and this, and you do that to it, and you get some product. So we're going to take a very simple recipe for a sandwich. And our recipe here is 2 slices of bread, 3 slices of meat, 1 slice of cheese gets you a sandwich. You could pretend you're working at, Quiznos or Subway or something. And this is your recipe. This is how you make the sandwich. In order to make the sandwiches, we need to know what the ingredients are, and we need to know the amounts. How much meat are you supposed to put on that sandwich? Now, the recipe can be scaled up to make larger amounts of products. Say you've got a big order, somebody's having a party, and they want 100 sandwiches. What do you do to the recipe? You just multiply everything by 100, right? So if you want 100 sandwiches, then you're going to start with 200 slices of bread, 300 slices of meat, and 100 slices of cheese, and put them together appropriately. So these coefficients correspond 200 to 300 to 100 to 100 correspond to the ratio 2 to 3 to 1 to 1. The same as the coefficients in the balanced equation, or recipe for the sandwich. So we're just multiplying all of those coefficients by the same number, whatever number we want it to be, and it's still balanced, right? If you're going to double a recipe, you double everything. If you're going to quadruple it, you quadruple everything. If the recipe is too big, you can cut it in half. In a chemical equation, it's much the same. Here we have a balanced chemical equation. This is ethanol reacting with oxygen to form carbon dioxide and water. 1 molecule of ethanol reacts with 3 molecules of oxygen to make 2 molecules of carbon dioxide and 3 molecules of water. That's what the coefficients mean. This equation is balanced. If we compare the numbers of carbons, hydrogens, and oxygens on each side, they are the same. All the atoms present in the reactants are accounted for in the products. We don't have any oxygens disappearing. We don't have any hydrogens appearing out of nowhere. Just like if you're going to make those sandwiches, you're going to start out with the right amount, and you're not going to have any disappearing. There's no snacking that goes on during a chemical reaction. So if it's true that 1 molecule reacts with 3 molecules, then it's also true that 1 mole of ethanol reacts with 3 moles. It would just be like, making a dozen sandwiches, right? You'd need 2 dozen pieces of bread. Any questions? So let's look at this example. One of the key steps in producing pure copper from copper ores is this reaction of copper sulfide reacting with copper oxide to make copper and sulfur dioxide. And they're pointing out to us here this is unbalanced. After balancing the reaction, okay, let's do that first. Let's balance the reaction first. So let's look at the coppers. How many coppers are on the left side of this equation? 4. There's 2 here and 2 there. So a good place to start might be to fix up this guy and put a 4 there. So now we have 4 copper atoms on each side of the reaction, the equation. How many sulfurs on this side? Just 1, right? And there's 1 over here, so that's all good. How many oxygens? On the left there's only 1, and on the right there's 2. So that's kind of a problem, isn't it? Well, even though it's going to mess up the copper, we're going to have to put a 2 over here so that we have 2 oxygens and 2 oxygens. Now we need to recognize we screwed up on the coppers here, so we have to go fix those. So let's look at copper again. There's 2 coppers here, and now we have 4 here, a total of 6. But copper over here is all by himself, and so we can change that 4 to a 6 without messing anything else up. Everybody okay with that balanced equation? Now let's look at the question. Determine how many dozen copper atoms could be produced from a dozen molecules of the sulfide and 2 dozen of the oxide of copper 1. So this equation is telling us that 1 molecule of copper 1 sulfide reacts with 2 molecules of copper 1 oxide to form 6 atoms of copper and 1 molecule of SO2. That's what those coefficients mean. What this is saying is, what about if we did dozens? So we can actually just kind of insert a counting unit like dozen in there. Because when we're doing this, and that's a 1, all we're doing is we're multiplying all the coefficients by 12, because that's what a dozen means. So just like we made 100 sandwiches by multiplying all the ingredients amounts by 100, here we're just multiplying by a dozen. So now we say 1 dozen of this reacts with 2 dozen of that. So it says, how many dozen copper atoms could be produced from a dozen molecules of the sulfide? There's the sulfide, and in our reaction we have a dozen, and 2 dozen of the oxide of copper. Well, here's the oxide, 2 dozen. So from 1 dozen of this and 2 dozen of that, how many dozen copper atoms? 6 dozen, right? 6 dozen. That's the answer to the first question. Any questions about that? And then it goes on, also how many moles of copper could be produced from 1 mole of the sulfide and 2 moles of the oxide? Well, mole is a chemist's dozen. So we could say that 1 mole of that reacts with 2 moles of that to make 6 moles and 1 mole. We use mole just like we use the unit dozen. So 1 mole of this reacts with 2 moles of that to make how many moles of copper? 6 moles. Okay? This is a really important idea, but it's not that hard, is it? We're just multiplying. It's this weird number, and we know what it is, but we don't actually end up using it much anymore. So 1 mole of copper sulfide and 2 moles of the copper oxide would make 6 moles of copper atoms. This is understanding what that chemical equation is telling us. Any questions?